Hey guys, so today let's talk about construction of binary tree from preorder and inorder traversal. So I'm going to directly take an example from lead code. So the given example for preorder is something like so 3, 9, 20, 15 and 7, and in order is 9, 3, 15, 20 and 7, and the result that we are looking for is like this 3. Okay, so the question is very straightforward. Using these two informations, how can we form this guy? Okay, so let's first understand what pre-order traversal is and what in-order traversal is, right? A pre-order traversal is root, left and right. I denote root always with T, with L and R. Okay, and in case of in-order traversal, it is left, root and right. So one easy way to remember this ordering is in-order traversal is always for a BST, which is a binary search tree. In-order traversal is always it will print the results always in ascending order. So let's take a look at that example. So let's build a BST here. If you have something like so, like 5, 1, 10, you can go to -5, 4 and like 6 or 20, something like that, right? So if you see, this is a binary search tree, meaning from the root every node that is inserted next is structured in a way that actually either goes to the left or right. So 1 is less than 5, so it goes to the left. 10 is greater than 5, so it goes to the right. Then -5 is obviously less than 5. It is less than 1, so it goes to the left here, like this. And 4 is less than 5, it goes to the left, but it is greater than 1, so it goes here. And similarly 6 is greater than 5, but it is less than 10, and 20 is greater than 5 and greater than 10, so it goes here. So this is a binary search tree. Now if you write an in-order traversal, you can blindly write this result in an ascending order, meaning -5, 1, 4, 5, 6, 10, 20. I didn't even calculate it, right? I just took the integer numbers and I wrote in ascending order. That is my in-order traversal. So if you remember this, it's a hack, right? If you remember this, you can quickly figure out that the structure is left tree, left root, and the right is the structure. So pre-order is always very easy to remember. On the first one is always root. So anyway, let's go back to our problem. Now that you have this information, I will write them down again here. In order is left tree, root and right. Pre-order is root, left and right. Okay, there you go. Now what are the values given to us here? Okay, in order is 9, 3, 15, 27. Pre-order is 3 9 2015 7. So look at pre-order. Pre-order is giving out a flat out information of what the root value is. This is the root value, right? Because you're always starting at root here, right? So that means you can form something like, if you look at pre-order, you can say that, okay, tree node root is equal to new tree node of, if I call this pre of 0, that is your root node, right? So far this is the easiest thing to figure it out. But how can an inorder traversal help us here, right? If you look at this problem, the inorder is, the tree is in sandwiched in between left and right, meaning if I can find the root value in the in order, this left half becomes the left, this right half becomes the right, correct? So if I can easily find out where the root value is, I can somehow recursively go to the left and go to the right and build out the tree. For me to build this or easily look it up, I can basically say, this is step number 1. Obviously, in step number 2, find the location of root.val in order. Okay, then step number 3 is recursively go to left, build left side, build left branch or left subtree, and similarly build right subtree. Okay, now how can I easily look it up? Obviously I can look up if I can convert this in order into some kind of a constant time lookup, like a set or a map, right? So if I can convert this into a hash map, what am I converting? So okay, I need to find the location in order, right? So if I can convert and this in order into some kind of an hash map where key and a value will be, see, I need the location, right? I need the location in this. So obviously the key is 3, location will be 1. So other locations will be like 90, okay, 1527, something like that. So if I can find this out, then I can easily go and attack this step number 3. So let's look at the whole thing in some kind of a code, right? So the result would be tree node, and I'm taking the signature from lead code, and what is it saying? I am getting an int of pre, another integer array of in. Okay, that's fine. Now here line number 1, I'm going to say map of int this is an in map, in order map. I'll just say like build map in. Okay, the build map function is basically constructing this guy. So let me connect this like this. the build map function is that. Okay, that's great. Now I need to locate. So if I have like a global result or something, tree node root of some kind, and the initial root has to be the first location of the pre-index. So I can also have something like root is equal to pre of 0 instead of 0, because I need to progress. I will take into some kind of a global index. I will say int pre-index is equal to 0, something like that. Yeah, there you go. And instead of this line, I'll just write pre of pre-index. Okay, great. Now I need to increment this guy, but now that I formed this value, I need to locate in the Inorder map. So if I have another integer of in index is equal to 0, right? Then in index is, what is this, in map dot get root dot value. Correct. The reason for this line is this step number 2. You need to find the location of this 3 in the in-order map to determine what my left and right would be, right? You can have a helper function, something like, helper function, where you are taking the left index and like the right index or something like that, and you can call this helper function to actually build this map recursively. So what you can say is uh, helper. So you can actually this is what I would do. What I would do is I would say I would construct this root here. Actually, I would construct this root here. I will say root is equal to pre of pre-index. That's fine. Then I would also say int in index is equal to, what is that, in map, right? Okay, in map dot get root dot value, and I can say helper of left index comma in index. This will become my root dot left, correct? And here I'll say root dot right is my helper, which is from next point, which is in index plus 1 comma right. Okay, and yeah, that's pretty much, that's pretty much it. All I need to do is I need to increment this guy here, because once I tackle this 3, then I need to move on to 9, then I move to 1, etc, etc. I need to move on. So that's that. And so this actually is covering step number 2 and 3, or what, step number 2. So instead of these 2 lines, I'm going to just say I'm going to call this helper function I'm going to say 0 and I'll say preorder dot length, and I will return root here. Yeah, that's it. That's it. So again, let me repeat it just a little bit again. So because the code I wrote it all over the place, right? So let me repeat this one more time. So if you have an pre-order and in order, right? The pre-order structure is root first, left and right. In order structure is left, root and right. Now using these two, you can actually figure it out. I'm gonna take an example of, I want to take a hypothetical example, but it is a little bit cumbersome to actually build it out. So I'm gonna just write this same example back. So 3 9 20. I'm just copying this from the lead code example given. In real cases, you would probably build one simple tree structure and you can actually go from there. Not a big deal. Um, yeah, so you obviously know that the first element in the preorder is the root element. So root, you basically form this root to begin with, no problem, right? Now you need to find the left side of the things and the right side of the things. For you to find the right side of the things, the in order is giving you a clue saying that, hey, if you take a root at any given point of time, this guy is sandwiched in between the left side and the right side. Meaning, if you can find where the root value is, the left side will be the left side of the things, right side will be right side of the things. Meaning, I found this 3 in order. It is sandwiched between left and it is sandwiched between left and right. So immediately my left is, because I only have like one element, it's basically 9, right? Now look at right side of the things. Now when you come to right side of the things, how would I determine what is the root here, what will be the root here, and will I have something like that or will I have something like that? We don't know that structure. So first order of business is to determine what the root is. So if I recursively go here and I'm saying that, okay, uh, now my in order is 15 20 7, and my pre-order has become 20 15 and 7. Because I took care of 9 and 3, I am progressing from left to right. I took care of 9 and 3, we are done. Okay, and now if I go to pre-order, the immediate the first one is 20, so immediately it fills 20 here. Okay, and I will try to locate this 20 in the in order integer array, and I'm trying to figure out what my left is, which is basically 15, what my right is, which is basically 7. The same thing happened with 9 as well. I mean, if you have a root value here and a huge tree, then in the pre-order structure, in the in order, you can imagine of having a root here and left side values and right side values here, and you will recursively go to the left and right and you can try to build this tree. I hope this makes a lot of sense. The code is this code, I think it will definitely work. I have to write it down, but the logic doesn't change. As usual, the code is already, the link for the code I will put the GitHub link in the description. And yeah, good luck guys.